Hey guys, I'm back. I am discussing complex numbers today with you guys. And so the big question, of course, is how do complex numbers come about? This is how the complex numbers come about, guys. When you have square root of negative 16 and you type this into the calculator, the calculator will produce an error message. The reason why the calculator produces an error message is that there's a negative inside or under the radical. The calculator doesn't know what to do with that negative. It doesn't comprehend the negative. However, if you were to take the square root of negative 16 and separate it into the square root of 16 times the square root of negative 1, in other words, you separate out the negative from the 16, so now you can actually figure out that the square root of 16 works on the calculator. It's that negative 1 that's preventing it from working on the calculator, guys, okay? So since that is the case, once you separate it, it becomes so much easier. The calculator can now calculate the square root of 16. And then, of course, that square root of negative 1 is where that unit comes in, that imaginary unit comes in, okay? The I is defined as the square root of negative 1. In other words, the square root of negative 1 is defined as the imaginary unit I, guys, okay? My pen is not writing very well here, so hang on a minute. Let me go ahead and backtrack so I can come back in and write all this down for you guys. So let's go ahead and erase some of this stuff, okay? Oops. All right, there we go. Okay. So guys, that square root of negative 1, we are going to define it as the imaginary unit I. That's the imaginary unit. Okay, sometimes you'll hear people refer to it as the pure imaginary unit. And there's nothing wrong with that. And, you know, whether pure or not, it's still an imaginary number. So since square root of negative 1 is defined as I, then you would go ahead and do a quick substitution. For the square root of negative 1, make it I, and square root of 16 would be 4. So 4i in and of itself is referred to as a pure imaginary number. A pure imaginary number. And so, guys, once we know that, we can then go back and define a complex number, guys. A complex number, when we look at it, it consists of a real number and an imaginary number, okay? We're gonna get to that in a minute. Now let's look at some additional examples. Square root of negative 100. If we had to simplify that, once again, remember it's that negative under the root that's preventing the calculator from computing this. So if you were to separate it so that you have the square root of 100, and then the square root of negative 1, you can now simplify this to 10i. The square root of 100 is referred to as the real number part. And of course, the square root of negative 1 is referred to as the imaginary part. Now, obviously, there's that intermediate step there where I separate the square root of 100 from square root of negative 1. You don't have to do that, guys, okay? I'm just showing this to you so you understand where everything is coming from. So if I were to give you the square root of negative 36, you should automatically go to 6i. Square root of 36 is 6, and then the negative becomes an I. Likewise, if you were given square root of negative 2, be careful with that, guys, because we're going to have to keep the square root. The imaginary unit would be the coefficient of the square root. So you want to keep the I in front of the radical. Don't write it after the radical because you don't want to make it seem like the I unit is inside the radical. So it's best to write the I unit in front of the radical, okay, to avoid confusion, all right? So additionally, guys, once we start looking at these complex numbers, a complex number is simply, people, simply this, okay? It consists of, it's made up of a real number and an imaginary number. A real number and an imaginary number. When we talk about the complex number form, we're looking at a number in the form of a plus bi, a plus bi. So then the a value would be considered the real number part, And then the BI would be considered the imaginary unit part, okay? So guys, this is what a complex number looks like. So now let's go ahead and look at a concrete example. Now, here's a concrete example of a complex number. Let's say you have something like this, guys, 3 plus 4i. The 3 is called the real number, and then the 4i would represent the imaginary number part. So then the big question is, what can we do with these complex numbers? Yes, I hear you. We can add or subtract them. And when you're adding, subtracting these complex numbers, you add or subtract them just like you would any real number, okay? Like the polynomials we just finished. So guys, listen, it's the same rules. So when it comes to the complex numbers though, you gotta do the real number part with the real number, and then the imaginary with imaginary. So you're just combining like terms, so real with real, imaginary with imaginary. So let's go ahead and do a couple of examples of this, okay? So let's say you had these two complex numbers right here and you wanted to add them together, 3 plus 4i, and then plus 5 minus 2i. So here, guys, it's easy. What you do is you take the real numbers, you add them together. So you do the 3 plus the 5, so that would give you 8. And now you would take the imaginary units and add them together. So you would do 4i plus negative 2i, which would give you 2i, and just like that, you're done, guys. I'm telling you, it's easy, very straightforward, okay? This is not a difficult process. Number 2, let's say this time we're finding the difference between the two complex numbers, okay? So in the case of this one right here, what I recommend you do is to distribute the negative over the second parentheses. And once you distribute the negative over the second parentheses, you would be left with 3 plus 4i minus 5 plus 2i. And just like with the previous problem, you combine the real with the real, the imaginary with the imaginary. So in this case, you would do 3 minus 5, which gives you a negative 2. And then 4i plus 2i would give you 6i. And that's it, okay? So guys, as you can tell, this is super easy, super duper easy, okay? So next, we're going to go ahead and move on to multiplication. Now, when it comes to multiplication, guys, okay, what you have to realize is that the second rule for these complex numbers is this. Whenever you encounter an I squared, you have to convert it to -1. I squared becomes -1. So I hear some of you, why does I squared become -1, Miss Alcira? Here's why, okay? In order to get to I squared, you would have to do I times I. And so since the imaginary unit represents the square root of -1, this would represent square root of -1 times square root of -1. And so I times I would give you I squared. And likewise, on the right side, square root of -1 square root of times square root of -1, you can rewrite it as square root of -1 squared. And what happens when you have a square and a square root? They cancel each other out. So what are you left with? -1. And yes, guys, that is why I squared is equal to a -1, right? So now let's get into some examples of multiplication. The best way to learn the multiplication is through some example problems. So let's start off with number 1, where we are multiplying a real number and an imaginary number together. Okay, so on this one right here, we're going to go ahead and do 4 times 3i. 4 times 3i, guys, produces 12i. Very straightforward. That's it. Okay, you don't have to do anything else with that. But here's where you need to be careful. When you're multiplying 2 imaginary numbers together, 4i times 3i gives you 12i squared. And then I squared, okay, is equal to -1. So wherever you find I squared, you got to convert it to -1. So this would become 12 times -1, which gives you -12. Got to remember that, guys, okay? Number 2, let's say this time you're going to go ahead and take an imaginary number and distribute it over a complex number. So you want to go ahead and take that 4i and multiply it over the parentheses. So you want to multiply it by 5 and then multiply it by the negative 2i. So 4i times 5 gives you 20i. And then 4i times negative 2i gives you negative 8i squared. So remember, I squared is equal to negative 1. So that negative 8i squared will become positive 8 because negative 8 times negative 1 gives you a positive 8, guys, okay? And that's it. Yeah, that was number 3. Now, remember, guys, it's best to write these answers in the form of a plus bi, as in the real number first, followed by the imaginary number. So you might want to take this answer right here and rewrite it as 8 plus 20i. So it mimics the complex number form, all right? It's not required, but it's good to know that when you write your complex numbers, they are in the form of a plus bi. All right, next one, guys, number 4. Now, for problem number 4, we're just multiplying 2 binomials. And just like you did with the polynomials, when you were multiplying 2 binomials, you FOIL. Similar process here, guys. We're going to FOIL it out, okay? Just FOIL it out, seriously. So here, you would take the 3 multiplied by 5. Take the 3 multiplied by negative 2i. And then you want to take the 4i multiplied by 5 and take the 4i multiplied by negative 2i, okay? So 3 times 5, 15. 3 times negative 2i, negative 6i. 4i times 5 is 20i. 4i times negative 2i gives you a negative 8i squared. Combine like terms, negative 6i plus 20i is going to give you 14i. Bring down the 15, of course. And minus 8i squared becomes, let's go ahead and change that, okay? So let's just go ahead and put positive 8 because negative 8 times negative 1 gives you positive 8. And then the last step is to combine the 15 with the 8. So that gives you 23 plus 14i, okay? So guys, as you can tell, this is pretty easy. We're just building on previous knowledge we had. We're adding the imaginary units now. It's still the same process, okay? So let's go ahead and move on to the next example, and that is number 5. This is where we have a binomial square. And when we have the binomial square, guys, remember, it's always best to go ahead and take the binomial and rewrite it so that it's multiplying by itself. And of course, you want to use FOIL to carry out the multiplication process. By the way, guys, you do have calculators that can do this on your basic scientific calculators, some of you, as well as the graphing calculators. Definitely, you can do this on the calculators too. So here we're FOILing 3 times 3, that's 9. 3 times negative 2i gives you a negative 6i. Negative 2i times 3 gives you negative 6i. And then that gives you positive 4i squared. Okay? So we combine negative 6i and negative 6i. It's going to be negative 12i. And then 4i squared becomes negative 4. And then you add the 9 and the negative 4. So it's going to be 5 minus 12i, okay? So guys, again, very easy problem, okay? Imaginary numbers, complex numbers, they're not that difficult at all, guys. Just remember, if you're doing this on the calculator, on the graphing calculator, if you look above the decimal, you will find the imaginary unit there on the graphing calculators. On your basic scientific calculators, you actually have to look for the imaginary number. It's not in the same location for everybody. But on those TI graphing calculators, it's always above the decimal point. You will find the imaginary unit. And when you type it into the calculator, you type it in exactly like you see it. Like this one we just did, you would type in parentheses, 3 minus 2i, close the parentheses, square it, and the answer will come out. All right, guys, here we go. 3 minus 2i times 3 plus 2i. We're going to multiply the conjugates together. All right. Yeah, this is where I realized, wait a minute, I'm not hearing anything. Maybe, okay, my mic is not working. And yes, again, yeah, I was on mute, guys, okay? So, I'm gonna stop talking right now. I know. I do this all the time. All the time. Yeah, I forget to remove the mute, take the presentation off mute for some reason. I don't know what comes in with the mute button on, guys. Yeah. And then when I'm almost done with the presentation is when I realize, oh, okay, I'm on mute. What the heck? Anyways. Guys, my computer has been on mute the entire time. I just realized that. I was just joking about how the iPad is on mute. Come to find out my computer was also on mute. Shazam. I'm going to have to record over this entire thing, okay? Up to about this point. Yeah. So guys, let me go ahead and finish this so I can go back and record over it. I can't believe it. So anyways, right now I'm multiplying these two conjugates together. We call them conjugates, guys, because the two binomials are almost identical except the signs in the middle are different. And so on this one right here, to multiply them together, we're going to multiply the first two and the last two terms together. So 3 times 3 is 9. Negative 2i times 2i is negative 4i squared. And of course, whenever you encounter the I squared, you have to change them to a negative 1. So this actually becomes positive 4. And when you add it together, you get 13. So there's your answer. Okay. So let me go ahead and clear this one out. Now, just a quick word about division, guys. Division with the imaginary units. When it comes to division with the imaginary units, what you have to realize is that you're not allowed to have i's in the denominator. No i's in the denominator. No i's at the bottom, all i's up top, okay? No i's in the denominator, guys. So you got, if you encounter an imaginary unit in the denominator, you have to eliminate it from the denominator. I'm not supposed to talk about this particular section, but guys, I have to. I cannot not talk about this, okay? So I'm going to, okay? So there's basically two types of problems you'll encounter with the imaginary unit in the denominator. One is where you have a single term with the imaginary unit in the denominator. And if that should happen, to eliminate the I from the denominator, all you do is multiply both the numerator and denominator by I. Here, let me use a different color. Multiply the numerator and denominator by I, guys. And that's about it, okay? So when you multiply here, you get 3i over 2i squared. And of course, I squared is equal to negative 1. So this would become 3i over negative 2. But you don't want to leave the I in the negative in the denominator. That needs to be either mid-fraction or in the numerator. So this would become negative 3i over 2. And that's it, guys, okay? So that's the first type. And then the second type that you will encounter with the imaginary unit in the denominator is where you have, guys, where you have a binomial containing an imaginary unit in the denominator. So if you have a binomial containing an imaginary unit in the denominator, this is how you're going to deal with it. You're going to find the conjugate of the denominator. And so this denominator here is 1 plus 2i. So its conjugate would be 1 minus 2i. And then you want to multiply both the numerator and the denominator by the conjugate. Okay? So in the numerator, it's easy. We're just going to multiply 3 times 1, 3 times 2i. So we get 3 minus 6i. Now in the denominator is where you have to be careful. You're multiplying two conjugates, so you multiply the first two, last two. So 1 times 1 is 1, 2i times negative 2i is negative 4i squared, 4i squared. And yes, guys, you can do this on the calculator too, okay? So if you're going to do this on the calculator, just be careful. You would have to enclose that denominator since it's got two terms inside a set of parentheses. So you would do 3 divided by, open parentheses, 1 plus 2i on a calculator. All right, guys, so let's finish this one out. So in the numerator, we have 3 minus 6i. In the denominator, we'd have 1 plus 4, 1 plus 4, and 1 plus 4. How did we get the plus 4? Because we have the I squared, guys. I squared is equal to negative 1. So negative 1 times negative 4 gives you positive 4. Now, 1 plus 4 is 5. Now, this is perfectly fine, except you got to write these in a plus bi. So the acceptable way to write this answer is 3/5 minus 6/5i. Either the I is mid-fraction or in the numerator, guys. So this is the final way. You won't see problems like this on the assignment, but I needed to mention that you're not allowed to have i's in the denominator. So if you should ever encounter these problems where you have an imaginary in the denominator, you have to eliminate it from the denominator. Okay, guys? And I've showed you the two options, the two ways you might see it, and how to eliminate them. So really the work is up to the multiplication, okay? So I am done. Of course, I'm gonna have to go back and record the first part of this, okay? We recorded. But for now, guys, I am done going over complex numbers. And so until next time, bye everybody. Oh, I should have used a different color here. Let's use a different color. Bye everybody, okay?